Now I would like to revise my previous class discussion about subtraction of vectors. Those who are interested to write the notes, they can take the notes from the summary I am going to discuss now. So if they want to write the notes on paper, the notebook, they can, after every page, they can take a pause and write the notes also. So once again, you listen from beginning of subtraction of vectors. If A bar and B bar are two vectors, then the vector difference A bar minus B bar defined as another vector, which is the vector sum of the two vectors A bar and minus B bar. So in the diagram here, the direct line segment OA bar represents the vector A bar. The direct line segment OB bar represents the vector B bar. Theta is the angle between the two vectors A bar and B bar. It means the angle BOA is equal to theta. The direct line segment OB1 bar represents the vector minus B bar. From definition of negative vector, the vector minus B bar has same magnitude as the vector B bar. The direction of vector minus B bar is opposite to the direction of vector B bar. In the figure, the two vectors B bar and minus B bar, they are shown along same line in opposite directions. So the angle BOB1 is 180 degrees. Angle AOB1 means it's the angle between the vectors A bar and minus B bar. That is equal to angle BOB1 minus angle BOA. Angle BOB1 is 180 degrees, angle BOA is theta. That means angle AOB1 is 180 degrees minus theta. So if theta is the angle between the vectors A bar and B bar, the angle between the vectors A bar and minus B bar will be 180 degrees minus theta. So on writing the discussing the graphical method here for finding the difference of the vectors, the vector difference A bar minus B bar can be written as vector sum of A bar and minus B bar. The diagram I have shown earlier, the vector A bar is represented by direct line segment OA bar. The vector minus B bar is represented by the direct line segment OB1 bar. And OA DB1 is the parallelogram. We'll once again go to the diagram. OA DB1 is a parallelogram. So from parallelogram law of addition of vectors, the vector sum of OA bar and OB1 bar will be equal to OD bar. That means OD bar represents the vector A bar minus B bar. So from parallelogram law of addition of vectors, we have square of the magnitude of resultant of two vectors P bar and Q bar is equal to square of magnitude of first vector P bar plus square of magnitude of second vector Q bar plus 2 into magnitude of P bar into magnitude of Q bar into cosine of the angle between P bar and Q bar. So using this equation, we can find the magnitude of the vector A bar minus B bar. A bar minus B bar is the vector sum of A bar and minus B bar. So here you can substitute on the left hand side P bar equal to A bar and Q bar equal to minus B bar. Even on the right hand side also you can substitute P bar equal to A bar and Q bar equal to minus B bar. An angle between P bar and Q bar means it is the angle between A bar and minus B bar. The angle between A bar and minus B bar will be equal to 180 degrees minus theta. So in the figure, if theta is the angle between A bar and B bar, the angle between the vectors A bar and minus B bar will be equal to 180 degrees minus theta. So we are trying to find the magnitude of the vector OD bar, that is magnitude of the vector A bar minus B bar, using this equation. So we have substituted here left side P bar equal to A bar and Q bar equal to minus B bar. Even on the right hand side I have substituted P bar equal to A bar and Q bar equal to minus B bar. Angle between P bar and Q bar is 180 degrees minus theta. Means angle between the vectors A bar and minus B bar is 180 degrees minus theta. Mod of A bar you can write as A on the right side. Modulus of vector minus B bar is same as the modulus of vector B bar, which you can write as B. Here also you can write mod of A bar equal to A, mod of minus B bar equal to B. Don't write mod of minus B bar as minus B. Modulus of vector cannot be negative. So modulus of vector minus B bar should also be written as B. Now cos 180 degrees minus theta equal to minus cos theta. So I can substitute here cos 180 degrees minus theta equal to minus cos theta. So the magnitude of the vector difference of two vectors A bar and minus B bar is given by mod of A bar minus B bar equal to root of A square plus B square minus 2AB cos theta, or mod of A bar minus B bar equal to root of A square plus B square plus 2AB into cos 180 minus theta. In this equation, theta is the angle between the vectors A bar and B bar. 180 degrees minus theta is the angle between the vectors A bar and minus B bar. Those who want to copy the notes, they can take the pause and copy the notes. Next, you see the special cases. Case 1, if A bar and B bar act in the same direction, an angle theta between A bar and B bar is 0 degrees. Then you get mod of A bar minus B bar equal to A minus B. If A is greater than B, mod of A bar minus B bar can be written as B minus A if B is greater than A. Mod of A bar minus B bar will be 0 if A equal to B. That means the two vectors have same direction and same magnitude, then the two vectors are equal. Then the vector difference will be 0. Vector. The magnitude of vector difference will be 0. So in general, if two vectors act in the same direction, then the magnitude of their vector difference will be equal to the ordinary difference of their magnitudes. Coming to the case 2. If A bar and B bar act in the opposite directions, then the angle between the two vectors A bar and B bar will be 180 degrees. So substitute theta equal to 180 degrees is the general equation for mod of A bar minus B bar. You get mod of A bar minus B bar equal to A plus B. Or modulus of A bar minus B bar, you can write mod of A bar plus mod of B bar. So if A bar and B bar act in opposite directions, then you can say that the vectors A bar and minus B bar, they act in same direction. In general, when two vectors act in the same direction, the direction of the vector sum of these two vectors will be same as the direction of any one of the vectors. Here A bar minus B bar, this vector is the vector sum of these two vectors. These two vectors have same direction. So therefore resultant of these two vectors will be same as the direction of either vector. That means if A bar and B bar act in opposite direction, A bar minus B bar acts in the direction of A bar. And mod of A bar minus B bar, you can write mod of A bar plus mod of B bar. So in general, if two vectors act in opposite directions, then the magnitude of their vector difference will be equal to the ordinary sum of their magnitudes. Case 3, if A bar is perpendicular to B bar, then theta will be 90 degrees. In that case, mod of A bar minus B bar will be same as mod of A bar plus B bar, and each will be equal to root of A square plus B square. But you cannot write A bar minus B bar equal to A bar plus B bar, because the directions of these two vectors are different. You can only say modulus of this vector A bar minus B bar same as the modulus of this vector A bar plus B bar. But these two don't have same direction. So you cannot write A bar minus B bar equal to A bar plus B bar here. You can write mod of A bar minus B bar equal to mod of A bar plus B bar. Then A bar is perpendicular to B bar. Coming to the special case 4. In general, suppose if two vectors A bar and B bar having same magnitude are inclined to each other at angle theta such that 0 degrees less than theta less than 180 degrees, and the vector difference A bar minus B bar will be perpendicular to the vector sum A bar plus B bar, and magnitude of vector difference A bar minus B bar is given by 2A sin theta by 2. Explain the calculation earlier for this conclusion, which I have directly given in the beginning now, in beginning of case 4. The same diagram which I have explained previously. In this figure, direct line segment OA bar represents the vector A bar. Direct line segment OB bar represents vector B bar. OACB is a rhombus, of course a parallelogram, because mod of B bar is same as mod of A bar in this case. So OAC bar represents the vector from A bar plus B bar, which bisects the angle theta between A bar and B bar. So theta by 2, this theta by 2 is the angle between B bar and resultant of A bar and B bar. This theta by 2 is the angle between A bar and A bar plus B bar. The direct line segment OB1 bar represents the vector minus B bar. OADB1, the parallelogram and again a rhombus, because the two vectors A bar and B bar have same magnitude. The direct line segment OD bar represents the resultant of A bar and minus B bar. So mod of minus B bar is same as mod of B bar, which is equal to mod of A bar. So in the figure, angle AOB1 is 180 minus theta. That is the angle between A bar and minus B bar. So the diagonal OD bisects the angle AOB1. Here, mod of vector OB1 bar is same as mod of vector OA bar. In general, if two vectors having same magnitude have different lines of action, then their vector sum or resultant bisects the angle between the two vectors. So here OADB1 is a rhombus. Modulus of vector OB1 bar is same as modulus of vector OA bar. So angle AOD will be half of the angle AOB. Angle AOD means angle between the vector A bar and A bar minus B bar. Angle AOB is 180 minus theta. Therefore, you get angle AOD equal to 90 minus theta by 2. That means in the figure OACB is a rhombus and OADB1 is also a rhombus. In the rhombus, the diagonal bisects the angle between the adjacent sides. So in the figure, the direct line segment OC bar represents A bar plus B bar. The direct line segment OD bar represents the vector difference A bar minus B bar. Therefore, angle between the vectors A bar plus B bar and A bar minus B bar is equal to the angle COT in the figure, which can be written as angle COA plus angle AOD. In the figure, you can observe angle COA is theta by 2. Angle AOD is equal to 90 degrees minus theta by 2. So, angle between the vectors A bar plus B bar and A bar minus B bar will be 90 degrees. That means in general, if two vectors A bar and B bar having same magnitude are inclined to each other at an angle theta such that theta is more than 0 degrees but less than 180 degrees, then A bar minus B bar is perpendicular to A bar plus B bar. The vector difference A bar minus B bar is perpendicular to the vectors of A bar plus B bar. For any value of the angle theta between the two vectors A bar and B bar, of course, only when mod of A bar is same as mod of vector P bar. Don't make a sweeping generalization that A bar minus B bar is always perpendicular to A bar plus B bar. We can say that vector difference A bar minus B bar is perpendicular to the vector sum A bar plus B bar only when magnitude of B bar is same as magnitude of vector A bar. And of course, mod of A bar minus B bar in this case will be 2A sin theta by 2. Now, I am going to show you some problems on subtraction vectors. You can take a paper and pen or notebook and pen with you. You may copy the problem on a paper. You can try it yourself first. I am also going to tell you the answers. Some of the selected questions I will be discussing in this class, and the other problems I will be discussing in my next class. Come on, look at the problems here based on subtraction vectors. Find the angle between the vectors A bar and B bar, and also the angle between A bar minus B bar and A bar in each of the following cases. Question number 31. Mod of A bar minus B bar equal to mod of A bar minus mod of B bar. Come on, think about the answer. And many of these problems come under one of the special cases which I have just discussed now. Therefore, you should be able to make out the answer very fast in such questions. I mean, those questions which come under special cases should be able to make out the answer fast without calculation. Come on, think about this question. So, wherever you need time for trying the problem, you can take a pause and try the problem. On the right hand side, I am going to show you the answers. So you get the answer as 0 degrees and 0 degrees. That means the angle between A bar and B bar is 0 degrees. And angle between A bar and A bar minus B bar is also 0 degrees. Next, look at the next question here. (32) Mod of A bar minus B bar is equal to mod of B bar minus mod of A bar. Looks similar to the previous question, but slight difference will be there. Come on, think about this question. In case you need time to think about the question, you can take a pause and think. The answer for next question is 180 degrees. That means the angle between A bar and B bar is 180 degrees. So for the question number 32, you get the answer as 180 degrees for both the parts of the question. That means the angle between A bar and B bar is 0 degrees. For first part of the question, you should get 0 degrees. The answer shown on the screen, 180 degrees, is the angle between A bar and A bar minus B bar. Only one answer is shown here. Again, I repeat, the answer for question number 32, the angle between A bar and B bar is 0 degrees. The angle between A bar minus B bar and A bar is 180 degrees. Then you see the next question here. Question number 33. Mod of A bar minus B bar equal to √3 times modulus of A bar plus B bar. And it is given that mod of A bar equal to mod of B bar. That means you are given the magnitude of vector difference A bar minus B bar is equal to √3 times magnitude of vectors of A bar plus B bar. And you are also given that magnitude of A bar is same as magnitude of B bar. This problem also comes under one of the special cases I have discussed. You can try this yourself first. If you want, you can take a pause and try. You get the answers of 120 degrees and 30 degrees. That means the angle between A bar and B bar is 120 degrees. The angle between A bar and A bar minus B bar is 30 degrees. Then next, see the question number 34. Here it is given that magnitude of A bar is equal to magnitude of B bar. That is equal to 1 by √2 times modulus of A bar minus B bar. Come on, try this question. Of course, each question you have to find the angle between the vectors A bar and B bar, and also find the angle between A bar and A bar minus B bar. In case you need more time, you can take a pause and try the problem. So you get the answers as 90 degrees and 45 degrees. That means you get the answer angle between A bar and B bar as 90 degrees, and angle between A bar and A bar minus B bar as 45 degrees. Then see the next question, question number 35. In this question, you are given that magnitude of A bar is equal to mod of B bar, that is same as mod of A bar minus B bar. Come on, try this. If you want, take a pause and try the question. The answers are 60 degrees and 60 degrees. That means you must get the angle between A bar and B bar at 60 degrees. and angle between A bar and A bar minus B bar also 60 degrees. You can see the next question here, 36. In this question, you are given that magnitude of A bar equal to magnitude of B bar, that is equal to 1 by root 3 times mod of A bar minus B bar. Here also again you have to find angle between A bar and B bar and angle between A bar and A bar minus B bar. Come on, try this question. Take a pause and try this problem yourself first. In case you need more time, you have to take a pause and try the problem. So you get the answers as 120 degrees and 30 degrees. That means you must get the angle between A bar and B bar as 120 degrees and angle between A bar and A bar minus B bar at 30 degrees. Similarly, you can try the other questions. I am showing the other questions and answers on the right side. For some of these questions, wherever it is necessary, use this. Particularly from 39 onwards, you can use these trigonometry ratios wherever it is required. Sin 53 degrees equal to cos 37 degrees equal to 4 by 5. Sin 37 degrees equal to cos 53 degrees equal to 3 by 5. In case you need more time to try these problems, you can note down these problems on a paper or in your notebook, and you can try them yourself first and check up the answers which are given on the right hand side. So in case you need explanation or working for all these problems, then you can see the working or my explanation in my next class. But those students who are able to solve these problems and who are able to get all the answers and who are confident of their answers, they need not go through the solutions which I discuss in my next class. They can skip the next class and directly they can go to the class after that, after vector subtraction. So then I am going to show you another problem. The magnitude of the resultant of two forces is 10 newtons. I am reading the problem here. Again I read. The magnitude of the resultant of two forces is 10 newtons. One of the forces with a magnitude of 10 root 3 Newton makes an angle of 30 degrees with the resultant. Find the magnitude of other force. Also find the angle between the two forces. Come on, you can take a pause and try this problem yourself. Those who need time, they can take a pause and try this problem yourself. So look at the next problem. That is also based on subtraction of vectors. A particle is moving with a velocity of 10 meters per second towards east at a particular instant. After 2 seconds, its velocity becomes 20 meters per second in the direction 30 degrees west of north. Find the magnitude and direction of the change in velocity vector of the particle. So, if you want to try the problem, you can take a pause and try this problem. So, you can try all these questions 31 to 41. The number questions with numbers 31 to 41. These are all based on the subtraction vectors. You can try those problems yourself first. And the next class after this, I am going to discuss and these problems, some of these problems. So, in case some of the students, they might have already solved all these problems and they might have got the answers. So, they can skip the next class. They can directly go to the class after that based on the relative velocity or so. So, those who need the explanation for these problems, they can see the discussions of the next problems in the next class. Okay.